Hello, everyone. So welcome to last session of the talks. So first of all, I would like to thank everyone who are watching us since long time. And so I would like to introduce you Mitchel. So he is going to talk about asp.netcore and geo-redundant deployments. So Mitchel, we are on you.
All right. Well, thank you so much for having me. Appreciate it. And great to have everybody here. Along the way, please do, if you have questions or anything that something that doesn't make sense on one of these slides here, be sure to ask questions. We really want to make sure that you have good understanding of things that we're talking about, and really want to make sure to set a good ground base for folks that are looking to get into geo-redundant deployments using asp.netcore and all of the different things that you need to take into consideration as part of your development best practices and processes along the way. So without further ado, kind of get into things a little bit here. A little bit about myself. I am a Microsoft MVP. I run a consulting company here in the United States, and we work primarily with ASP.NET, Microsoft technologies, so ASP.NET, .NET MAUI, all of those kinds of things. And we spend a lot of time working in Azure and redundant deployments. So everything that we're talking about here today is stuff that we've seen in real world scenarios, things that we've encountered with clients, trying to help modernize teams and get people thinking in a forward fashion as it relates to how you can deploy your applications and work inside of cloud environments where you need to be able to serve multiple geographic regions well, especially things such as uptime and other things for availability. So what we're going to talk about today is why geo-redundant? Why do we care? What are we trying to accomplish? And we're going to take a look at things that we need to do. What does it actually mean as a developer? What are the options? We're going to talk about some database architecture patterns, things that we can do at the database level, things that we need to consider as we build our applications or build our interactions. We're going to talk about application considerations, the things that we need to do at whether it be the web application layer itself, whether it be APIs, things that we need to do to make sure that we're working well. We'll talk a little bit about DevOps and deployment considerations. And then at the very, very end, we'll talk a little bit about costs and planning, some things that we can think about just to be able to get an idea of, okay, we're talking about this geo-redundant thing. What's that really mean? What does that cost look like? How big of a deal is it for us to be able to do something? So when I first started talking about geo-redundant deployments, I think one of the most important things is to figure out what we're going to accomplish. And as we look at the things that we might be able to accomplish with a geo-redundant deployment, I think it's important to understand what the goals are. Typically speaking, those that are looking for a geo-redundant deployment are looking for one of two things, either high availability. And when we talk about high availability, what we're talking about is those that are looking for a disaster recovery goal as their primary focus. They don't want their website to be down. They don't want their website to have any issues. They don't want a Windows server patching to impact their environment. We're not necessarily concerned on throughput or load or the number of people. It's all about keeping the site up. The second then scenario is typically those that are looking for regional deployments or performance gains with a geo-redundant deployment. They're either wanting to move the processing closer to the end users. Maybe, for example, they have an audience in the United States and they have an audience in Europe, and you want to prevent, all of those requests from having to go all the way across the ocean, right, to get from one side to the other. And they may be looking for faster response times under load scenarios. So as you get more and more traffic, being able to use multiple servers to be able to get things going. The real thing here is that when we try to go after some of these goals, especially the performance related goals, it may actually involve a combination of traditional local scaling as well as geo-redundant scaling. Geo-redundant scaling, no matter how you do it, definitely introduces some interesting things. So when we start talking about these architecture patterns and design patterns, it's important for us to take a look at what those kinds of things do, what are some of the pros and cons along the way. So, the last thing that we get from folks typically is, but I already have geo-redundant backups. I use GRS storage, or I have, these kinds of things. And so the key here is understanding where you're trying to go from an application perspective. Are you wanting to stay up with no downtime? Is it acceptable that you have a, hour of downtime for a site restore to happen? Those kinds of things along the way. So understanding those goals at the beginning becomes very, very important. As we continue and start looking at, what are we actually going to do, or how might we do it? There's a couple of different approaches and some key terms and terminology that's important for us to think about. If you look at Microsoft documentation, if you look at all of the examples that they have out there of here's how you can do this with Azure, or here's how you can do this in these other environments, you're going to hear the terms active and passive. Active meaning it's actively out there, it's being, it's serving traffic, it's doing what it should be doing. And then passive is ones that are, not necessarily directly serving traffic. And then you have the concept of cold and hot from a standby perspective. So the lowest hanging fruit, right, the one that requires the least amount of real consideration, is an active passive scenario where you have an active node and you have a passive node, and the passive node is considered a cold standby. And what we mean by these scenarios is that traffic goes to your primary region or your primary app service. The other environment, it's configured, it's there, but it's maybe not fully there. It's not set up to attract traffic. It may not be scaled to the right scale set, right? It may not be able to handle the load. It's kind of nice because it's there, it's mostly ready, but there's manual intervention involved. You may need to change connection strings. You may need to scale up a resource. You may need to make a DNS change. You have to do something to get that other environment online. Now, we still have to make sure that we're able to do that and move our application quickly, but we're not necessarily gaining real-time performance, real-time disaster recovery. Those kinds of things aren't going to be benefited with a active, passive, cold environment. Active passive with a hot standby, as you can imagine, then is where we take a situation, the traffic still goes to the primary region. Everything's going fine. We're still always in that primary region. The difference is that in this scenario, the other region is always ready. It's capable, able to handle traffic. There's no manual configuration needed. And then instant failover becomes possible. You can do this with things like a Azure Front Door or a Cloudflare or something like that, any type of active load balancer that looks and sees, oh, this environment is working, we're going to stay here. This environment's no longer working, send the traffic over to this other location. So you can get that instant failover and everything else. The key here is almost always, right? You now have two environments that have to have the same configuration, even if you're not using both of those environments at the same time. But that then helps you achieve that high availability, potentially even high throughput process, because both of those environments are available to you at all times. The final and most complicated is the scenario where you have active, where you are actively serving traffic out of multiple regions at the same time. If one region has issues, you simply take it out of the mix. So the same load balancer and service availability, service health items are usable. However, those environments are something that you end up needing to, you're always working. So when you write database changes, those database changes need to be done in a way that are instantly available for both of the applications. When you're working with, files, they need to be in a way that both environments have access to them. So as we start to think about how we might deploy these, we need to start looking at how we build our applications. What kinds of changes do we need to make? What kinds of things do we need to consider as we move forward? So if we start out at the database level, it's important to take a look at a few of the features that might exist out there today so that we understand what's available. Auto-sync replication. This is the concept where the database engine, whatever you're using, whether you're using Azure SQL or Postgres or whatever, Cosmos DB, et cetera, we need to understand, how do they take care of replication? How do they create a copy and keep that copy updated? We need to know the limitations. For a lot of them, secondary databases are typically readable, but they're not writable, right? Cosmos DB, for example, does support the concept of many masters, where each of the database can accept new entries and then they synchronize them together. Azure SQL, SQL Server with replication and those kinds of things, you still have a primary region. So you need to understand your application needs and where you want to go. A lot of times when you're looking for performance or other scale, you also separate the concept of reads versus writes, because it's very possible that reads could be done from a local database and writes still have to go back to the master database. So being able to separate the concept of reads and writes within your application may very well also help you accomplish some of those goals. So knowing the features, knowing what you have in your environment becomes really important. We then also want to take a look at, what are we actually doing in our database? Can we separate reads and writes? Are we utilizing transactions? What can we do to be able to change the application to potentially support this concept that we want to be able to work with SQL or our other respective database backends in a manner that is going to, accomplish the goal that we're looking for? If you can accomplish it, the performance gain of separating reads and writes is absolutely mind-blowing, especially in heavier load scenarios where you can take and spread that work between two different database instances. You get absolutely amazing performance gains. We also then need to kind of look at, how might we replicate? And looking specifically at Azure SQL, there's two other things that we can really do with a replication. If we have a big application, there's nothing wrong with creating two of the same database, even in the same region, because you can get that read performance gain if you're able to separate reads from writes. And then otherwise, right, we can utilize the two regions and do a regional failover. The failover process is all automatic. So if you're using Azure SQL, it's able to do an automatic failover. There's set criteria on how much data, granularity you might have, how quickly the failover happens, how you bring things back if they happen to fail over from one scenario to another. So all of those kinds of things are out there. It's really specific to the database engine that you're using. So again, if you're using Azure SQL, you want to take a look at it. We've got some links here. If you're using Cosmos DB, there's a different set of rules and criteria around these. The same concepts exist. Can you read? Can you write? Do you need to separate the reads and the writes? And where and how can you interact with the data to make changes within your application and not put yourself into trouble? As we dive just a little bit more into some of these failover scenarios, it's kind of interesting to look at what Azure SQL can handle from a geo-redundant deployment perspective. They can handle plan failovers. Think of these as, I'm deciding to fail over to the other location. I want to test my disaster recovery plan. I want to test my deployment scenarios. So the idea here is, you simply say, switch primary to secondary. It waits until all data writes have been synchronized. Then it's going to switch over from one to another. This is the kind of thing where you can do, it's really easy to do things for disaster recovery drills. It's also a really cool way to be able to move your data. Let's just say, for example, that you built your environment in Azure East US 2, you want to move to Azure West US. you can use the same concept of a high availability deployment to bring something over from one way to the other, because it waits until synchronization is completed, then it moves the data over. Now, unplanned failovers, these are the things that we all hope that we don't have a problem, but at the end of the day, this is the kind of thing that we're preparing for. It is something where we switch over to the secondary immediately. Any transaction that was in flux at the time will be committed to the primary, and the ones that maybe hadn't been synced yet are not applied. And so as we look at these items, the backup file is going to contain all of those things that didn't get applied. So you're not going to necessarily completely lose the data, but you're going to need to review from your perspective all of the things that happened in that backup file. So you might need to be able to replay those transactions. You may need to look at those. Once the primary comes back, it becomes the default secondary. So the instantaneous flip over, all of that happens. If your application is set up correctly, right, you're not going to see anything. And that's one of the things that we're starting to get with the geo-redundant deploy. ESUS2 goes down, you have a database backup, another replicated environment in central US, your application stays up and running. It's not going to then all of a sudden ESUS2 comes back. It's not going to automatically jump back over to ESUS2. You're going to have to take those steps on your own. You also then have the ability in Azure SQL to have up to 4 readable secondaries per primary. So you can actually, really do a lot of read scale out. Some things to think about, again, specifically for those of you that are using Azure SQL, the same concepts are going to apply if you're not using Azure SQL. If you're using regular SQL Server or you're using Postgres, just think about the things that you might be doing in your application. Firewall rules. Microsoft recommends to use firewall rules at the database level rather than the server. A lot of us get used to adding the firewall rules at the server level because it's easy. You add a new database, you still have access. The problem is that those rules don't get replicated. So in other words, I might have access to the database in production, but in the replicated environment, I don't have access to it. So they do recommend putting the firewall rules in there. You can take a look at all of your firewall rules that exist at the database with a simple query. Select star from sysfirewall rules. So it's something just important to kind of take into consideration as you're looking at your environment setup. The other thing that you want to take a look at is how you create those rules. So there is not an Azure interface for it, but you can go through and do your start and IP address ranges, all of the things that you do otherwise. Don't forget to update your connection strings. This is one of the things that we see all of the time. People set up an environment, availability zone, they do all of this stuff, but then they don't update their connection string to use the one that auto fails over. It's really surprising how often that happens. So don't forget, you set it all up. Your connection string is not going to be the same. If your connection string says EastUS2, it's always going to be EastUS2, right? Make sure you have that right connection string in there. Because otherwise, if you don't, you're going to get yourself into a little bit of trouble. So what does this look like? This is kind of how the environment might look, just so you can kind of visually see what would happen here. We can see over here that we have our application, Azure Traffic Manager. This could be Cloudflare. This could be anything else, but basically end user traffic on a good day comes over here into the primary environment. We have our application. If we can support read-only, right, we can use that secondary server with the auto geo replication. If something goes bad and this region is no longer available, our traffic manager, load balancer, etc., can bring our traffic over here, and then we can interact with those databases and those kinds of things. So at a high level, that's what we're looking to try to accomplish, right, is being able to get things going. Now, as we look at the application and we talk about how do we get to actually build our application and be able to support the concept of deploying to multiple regions, one of the number one things is that we should not have any scenarios where our application is making file system changes at runtime. This is one of the biggest things that we see a lot of times. We see this with content management solutions. We see this with applications where they accept, user inputs. There are no existing solutions yet in Azure for app service or anything else that allows you to replicate files 100% guaranteed cross region. We are getting more things where you can mount drives and things like that and put them into certain subdirectories. So we're getting closer and closer, but there's not a great solution for those kinds of things. So anything that you're taking user supplied content, updated content, getting those into things like Azure Blob Storage that is already geo-redundant, getting them into the database, getting them into somewhere that allows you to not have to necessarily keep those in sync, because the same region scale out, everything else, your scale outs don't necessarily work if you have file system changes at the runtime. So you want to make sure that you really truly think about that as you're building your application, as you're building those interactions with your end users and how they're providing you content. We want to make sure that you have all of the keys, all of the tools to really benefit yourself, and make sure that you're able to take those things into consideration. Other things we need to look at: caching mechanisms. How are we caching? What are we caching? Are we caching data, or are we always real time? And what do we do from a configuration of expirations? How do we go through and address those items? I'll talk about this a little bit more. The other item that we have is, what do we do from an application perspective to be able to support auto scale? What kinds of things can we do for our application to be able to provide environment health information? Am I overwhelmed? Am I responding well? Am I doing the things that I need to be doing? Is something that your application really needs to be thinking about. So as you're building your application, you're controlling how you accept user content, you're controlling how you cache, you're controlling how you monitor the effectiveness of your system and its overall operations day to day. So how do we take this into, okay, I need to think about this, to what do I do from a development perspective? File changes at runtime, absolutely simple. Azure Blob Storage, anything similar. Network shares absolutely work as long as you have a way to keep those network shares synchronized. So if you mount a network share that is coming off of an Azure Blob Storage account, you're usually okay. Caching mechanisms, I think, are the biggest thing that we see from a developer perspective, that they try to go after the ease of use route, and it causes you more trouble a little bit later. In asp.netcore, we have two types of caching that's built in. We have iMemory cache, which the nice thing about iMemory cache is that it's easy to use. The APIs are simple. You don't really have to do much. The downside to iMemory cache is that it is always an in-process in-memory cache. So if I have two servers, one in the East US and one in Central US, those caches are not aware of each other. So what we recommend is that regardless of what you're building, regardless of if you are deploying for scale, utilize iDistributed cache from the beginning. Because if you use iDistributed cache and you don't configure anything, for example, Redis cache or any other external caching mechanism, iDistributed cache by default will leverage a memory cache until you configure it to do something else. So what this does is it allows you to build an application today, and in 6 months, in a year, in 2 years, when you're like, oh my gosh, we need to scale this, you simply reconfigure iDistributed cache to point to Redis, and you're done. It makes life a heck of a lot easier to be able to plan ahead. The other thing then to really think about from an application development perspective is, how can you write a health check so that your application is able to say, this is healthy. Things you want to think about. Can I communicate to the database? Can I communicate to the file system? Anything that you might be able to, do or not do. Make sure that you build those into your application, because as you go to scale and you start using load balancers, the load balancers are going to want to know, is this server able to respond to requests? Is this server able to respond to requests? If you rely on your application alone to do that, you might end up hitting a really costly thing for a status check, right? Load balancers will often do status checks once every second, once every 5 seconds. You don't want it doing a costly operation all of that time, because you can actually overwhelm yourself with just your health checks and things that you need to actually get your application deployed and working well inside of an environment, all on its own. Now, things that we have to kind of look at as well become, how do we architect the actual environments that we're working with? So if I scale an environment from an app perspective, I don't have to use the same configurations. So in SQL, if I replicate a database and it's one size, the replicated database has to be the same size, same configuration. From an app service perspective, that doesn't necessarily ring true. I can take and create, an active hot, active cold configuration that uses much lower cost resources in my other environments. And, I could be 4 cores in production, and I could be 1 core in that cold environment. It's there, it's ready, the code is deployed, but it's not necessarily ready to handle heavy amounts of load. It's something you can do to really truly save yourself some money, especially on the application side. You can easily go from 2n, which is what you would normally be, right, for 2 web servers. You can easily be at 1.25n by simply scaling that second environment to much, much lower resources if it's not actively servicing requests. The other thing is, you get into some of these limitations where those manual steps introduce your changes. Quick scale up is harder because you can't just instantly fail over. So then you have to manually go through and do things. Some of your applications, right, may not even run on a single core servers, those kinds of things. And your ability to stay within the same family limits some of Azure's ability to go one click or otherwise to upgrade. The other thing that I think is really worth noting here is that some people get in their mind that I'm going to deploy in one region. I'm in East US, and I am running 2 cores and 8 gigabytes of RAM, and my application runs flawlessly. Some folks then get the idea of, what, I'm going to run it in both East US and Central US, but I'm just going to deploy 1 core and 4 gigs of RAM in each place because I have the same resources available. That is not necessarily a safe way to be thinking about your architecture, because each of those environments have certain amounts of overhead that are just there as part of that day-to-day. So, when you're trying to go for performance, you're trying to go to get that geo scale out there, you really need to make sure that you're thinking about how that is being done and ensuring that you don't get yourself into a situation where you actually cause more trouble than you get otherwise. Secondarily to that is, really low volume sites aren't going to see as much of a performance gain if they split their traffic to multiple servers, because part of the reason that you get performance gains under high load or with good server configuration is that caching mechanisms come into play. If I only get 20 requests an hour and they're spread out, and I have a 20-minute cache duration, right? My number of cache hits is going to be really, really low. So I'm still going to be going to the database, doing all of these round trips. If I'm getting 20 requests a second and a cache hit ratio is much, much higher, right? We're going to see an entirely different set of performance. So it's really, really important when you think about, I want to throw hardware at my environment to understand what does that mean? And it becomes really important when you think about just the general scale of what does this look like? The second that I say I want to be deployed in 2 different regions, you start getting to this kind of a level of Azure environment, and workflows or whatever, platform you're leveraging. And it's a lot more moving pieces. It's more interfaces for your dev teams and your IT support teams to be working with. So it's important to think about all of these things as you're starting to architect your solutions and looking at how you build things so that you don't get yourself into a situation where you are not able to answer something, or you're not able to say, oh, this is why we spend the money that we do along the way. Now, taking things from the how do I build, what do I do from a SQL perspective, how do I deploy, we also then have to take into consideration the things that happen from a deployment perspective. We have to think about how do we get our code to all of the places that we need to get it. You're obviously going to have changes to your CI/CD processes. You need to keep your code bases in sync. You need to deploy to all servers in the environment. So it's really pretty easy in a lot of cases, right, to just deploy your code all at once, do the same configuration swapping, doing a lot of the things that you're doing. Not a lot has to be done, but you have to remember from a CI/CD perspective that you are responsible for keeping the code in sync because you don't have that replication ability. From a SQL perspective, typically you don't really need to do anything because you're still writing to a master database and your database engine is taking care of all that synchronization. So you really shouldn't see a lot of changes from a CI/CD perspective as it relates to database activities. The only other things that you have to think about are those other configurations, things like your Redis configuration or Azure Blob Storage and those kinds of things, because again, you have those additional component parts. Those are things, though, that should be one-time configurations. If you simply get your application, your CI/CD processes, building and deploying these applications to all of their respective locations, it's going to be pretty easy to get things up and running. Now, one of the things that I always get from people is, what does this really look like from a bare bones? I want to deploy a small ASP.NET environment into an Azure cloud, and I want it to be geo-redundant and serving traffic from 2 regions at the same time. What does that look like from a cost perspective? It's kind of interesting. It's not nearly as expensive as one might think. So this is the bare minimum infrastructure to be able to accomplish a geo-redundant deployment. If we start at the top here, we have our traffic manager. So that traffic manager, that's our gatekeeper, right? That's our send it to this region, send it to this region based on health. The next 2 are equally paired app services. One that we would put in, a single region, the other we put in another region. Now this is looking at the bottom tier, 1 core, 4 gigs of RAM, completely adequate for certain application sizes. So you can see here, we have a slight difference in cost between one region to another. But basically we're looking at, $146 and $155 a month for the 2 different environments. We then have a primary and a failover database. You'll see here that Azure, basically each region, each place that you copy it, you simply pay twice for the thing that you have. If you have 3 copies, you pay 3 times. So we can see here it's an extra $29 a month. And then Azure Cache for Redis to get that out of process cache. That is something that the lowest here, the C0, I think, has like a 250 megabyte cache limit. That's $40.15 a month. All in all, if we look at this, we're at a total of about $407 a month to get an environment that would be geo-redundant, that is very capable of being able to serve traffic from 2 different regions at the same time. At the end of the day, it's $407 a month. If you look at it that way, if we were doing the bare minimum, right, we wouldn't need the $156.49 a month. We would not need the second database, and we wouldn't need the $40.50 item. So really, it'd be about $226 a month if we didn't have the extra scale. So it is fairly close to double in this configuration. Now, if this is a really busy app and we wanted to try to do some things like a cool environment or a cold environment, we can scale up that primary web server to have more appropriate things, and that's cost is going to go up exponentially, but we could keep that failover lower. So it's really pretty easy to kind of manage your costs, manage your expectations, but still be able to do it. As long as your application is taking these things into consideration. Where is it storing your data? How are you accessing the data? Are you caching information? And are you using caches that are appropriate for the types of environments that you're working with? So definitely something to make things a little bit easy. Hopefully, help kind of make things work. We got about 5 minutes left or so on our times here. If you have questions, things like that you want to talk about or want me to kind of get into, please feel free to put them in the chat there so that I see them. Would love to be able to answer any questions that you may have. Really, the whole goal with this is to give you an introduction into the things that you need to be thinking about from a deployment scenario, because everybody's situation is going to be a little bit different. So just making sure that you understand the concepts and things that go into how do I make a geo-redundant deployment become really, really important. So with that, I'll give everybody a couple of minutes here for questions. If you have something that you don't want to share publicly, if it's something that's very specific to your environment or your organization, by all means, please feel free to reach out to me directly. I will gladly answer any questions that I can, knowing that some folks, want to work with they have their own rules and things that they want to be able to do in terms of being able to share. I'll put my contact information back up here as well, just so that you have it. Again, reach out anytime with any questions you might have. My goal here is to make sure that we try to make development a little bit easier for everybody over time.
Thank you,
Alrighty.
Mitchell.
Thank you. Appreciate it.
So thanks for this great presentation, actually. Then as far as see from the Q&A section, I didn't see any question mark in the chat and the Q&A. However, you already shared your contact information. So people who are not going to, who couldn't see this presentation live because of time zone differences, so you can feel free to watch it later from this platform, and you can reach to Mitchel for your question marks. So before leaving, so Mitchel, I would like to thank you for your contribution. So I would like to say all people that so we can move to Ruffles and closing up. So see you guys in the next session.
Awesome. Thank you.